In October 2017, something entered our solar system. Fast, silent, and unexpected. It wasn't a comet, it wasn't an asteroid, and it didn't behave like anything we'd seen before. It was shaped like a long stick, or maybe a flat disk. It tumbled through space, glowing dark red, likely stained by radiation after millions of years in deep space. Scientists gave it a name, Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. But what truly puzzled them wasn't just where it came from, it was how it moved. As it passed the sun, instead of slowing down, it sped up. No visible gas, no engines, no explanation. Some thought it might be a comet with invisible gases. Others wondered if it could be something far stranger. Since then, scientists have been working to unravel the mystery. Today, we'll explore what we do know, what we think we know, and what we're still trying to figure out. This is the real story of Oumuamua. Welcome to Before the Light. On October 19th, 2017, a telescope in Hawaii called Pan-STARRS detected a tiny, fast-moving point of light in the sky. At first, astronomers thought it was just another comet. They labeled it C2017U1, but something didn't fit. Most comets develop a glowing coma, a fuzzy cloud of gas and dust when they get close to the sun. This object had none, so they reclassified it as an asteroid, calling it A2017U1. Still, things didn't add up. When they traced its path through the solar system, they made a shocking discovery. It wasn't orbiting the sun, it was flying straight through, on a path shaped like a hyperbola. That meant only one thing. This object came from interstellar space, outside our solar system. It was the first time in history we had ever seen something from another star pass by Earth. They gave it a new name, Oumuamua. In Hawaiian, it means a messenger from afar arriving first. And just like its name, it brought more questions than answers. As it tumbled through space, astronomers noticed its brightness change dramatically every few hours. That suggested an unusual shape, something very long, maybe up to 10 times longer than it was wide. Some said it looked like a cosmic cigar. Others thought it might be a flattened disk, like a pancake. Its color was a deep red, likely stained by billions of years of exposure to cosmic radiation. And though it was only a few hundred feet across, it was moving at breakneck speed, over 90 kilometers per hour, faster than any asteroid or comet we had seen before. But the strangest part, it left no dust, no gas, no trail of any kind. It was a silent traveler, drifting through our solar system like a ghost, and it was about to get even weirder. As Oumuamua moved away from the sun, astronomers noticed something truly strange. Instead of slowing down, like every normal object should, it sped up, just a little, a tiny boost, but it was real and measurable. Now in space, this usually happens with comets. When they get close to the sun, the heat causes gas to escape from their surface, like steam from a kettle. This acts like a tiny engine, pushing the comet gently. But here's the problem. Oumuamua didn't show any signs of that. No tail, no dust, no gas. Even the most sensitive telescopes saw nothing. It was like watching a boat glide across a lake with no oars, no engine, and somehow still picking up speed. So what could explain it? In 2020, one team suggested that maybe Oumuamua was made of hydrogen ice, the lightest and most delicate kind of frozen material in space. The idea was this: when heated by the sun, hydrogen ice could turn directly into gas and escape without leaving a visible trail. It was a creative theory, but it had a problem. Other researchers pointed out that hydrogen ice is too fragile. It would have evaporated long before reaching our solar system, kind of like trying to send a snowflake across a desert. It wouldn't survive. Then, in 2023, another idea emerged. This time, scientists proposed that Oumuamua was made of normal water ice. Like most comets, but over millions of years in deep space, it had been hit by cosmic rays, tiny, high-energy particles flying through the galaxy. These rays can actually change the chemistry of ice, slowly breaking apart water molecules and creating hydrogen gas. trapped inside like bubbles in frozen soda. Then, as Oumuamua got close to the sun, the gentle warmth released that gas, not all at once, but slowly, through tiny pores in the ice. The result? A soft, invisible push. No glow, no dust, just motion. It's a simple explanation. Using physics we already know, and while it's not confirmed, many scientists think this might be the most likely answer for now. Of course, not everyone agrees. Some have speculated that Oumuamua could be something artificial, maybe even a light sail, pushed by starlight, but most researchers say that's unlikely. A fascinating idea, but with very little solid evidence. So in the end, we're still left with mystery, not because we lack imagination, but because we don't have enough data. All we know for certain is this. Something pushed Oumuamua, and whatever it was, we've never seen anything quite like it before. So where did Oumuamua come from? That's one of the biggest questions, and the truth is, we don't know for sure, but scientists have ideas. When they traced its path backward through space, it seemed to come from the direction of the constellation Lyra, near the bright star Vega. But here's the twist. Vega wasn't even in that same spot when Oumuamua might have passed nearby. Why? Because the stars themselves moved slowly, but steadily over millions of years, which tells us one thing. Oumuamua had been traveling a very long time, possibly hundreds of millions of years, maybe more. But how does something even get kicked out of its home star system? Well, imagine a young solar system, just forming, planets are still shifting, colliding, jostling for position. A giant planet, like our Jupiter, could act like a slingshot. If a smaller object got too close, gravity could fling it out at high speed forever. That's likely what happened to Oumuamua. A leftover fragment, maybe from a comet or a frozen moon, got launched into deep space by a powerful planetary encounter. It drifted through the galaxy, alone and silent, passing near distant stars and dusty clouds. Some scientists even think it might be a shard of a larger world, maybe chipped off in a collision, like a piece of pottery broken during the chaos of planet formation. We may never know which star it came from, or what world it once belonged to, but we do know this. Interstellar objects like Oumuamua are probably common. Trillions of them may be out there, wandering between the stars, unnoticed. Oumuamua just happened to pass close enough for us to catch a glimpse. By the time we realized how special Oumuamua was, it was already leaving. It had looped around the sun and was heading out. Fast. Too fast for any spacecraft we had, too far for any telescope to keep tracking. It was like watching a ship disappear over the horizon and realizing you just missed something incredible. But some scientists said, what if we tried to go after it? That's where Project Lyra comes in. A bold idea to actually send a spacecraft to catch up with Oumuamua. Now, that's easier said than done. This object is moving at around 95,000 kilometers per hour, faster than anything we've ever launched. So how would we even try? One plan is called the solar slingshot. The idea is to fly a spacecraft close to the sun, really close, and use that gravity to gain speed. Right at the closest point, the engines fire, giving it a huge push outward, like pulling back a slingshot and letting go. But that kind of maneuver needs serious heat protection. Getting that close to the sun is no joke. Another option skips the sun and goes for gravity assists, using planets like Venus, Earth, and Jupiter to build up speed over time. It's safer, but slower. Either way, if a mission like this launches in the late 2020s or early 2030s, it could reach Oumuamua by around 2050. It's a long shot, but technically possible. And even if we can't catch this visitor, the real goal is to be ready for the next one. Oumuamua took us by surprise. We didn't see it coming. We didn't understand it fast enough. And by the time we realized what it was already gone. But next time, we might be ready. In 2025, a powerful new telescope will begin scanning the night sky from Chile. It's called the Vera C. Rubin Observatory, and it's built to catch things that move, like asteroids, comets, and maybe even more visitors from other stars. Some scientists think it could spot several interstellar objects every year, maybe more if they're small enough. And then in 2029, another mission will launch called Comet Interceptor. But here's what makes it special. It won't be aimed at a specific target. Instead, it'll wait out in space, parked and ready. If a new object is discovered, something like Oumuamua, this spacecraft can launch toward it. Chasing it down to capture up-close data, it's like having a camera already in the sky, just waiting for something strange to appear. Together, Rubin and Interceptor could change everything. We're no longer just watching the skies. We're getting ready to meet whatever comes next. Oumuamua came and went in silence, a small object shaped by time, weathered by space, that drifted through our solar system just long enough for us to notice, and then vanished back into the stars. Maybe it was just a piece of ice and rock, pushed by sunlight and invisible gas, or maybe it was something stranger, something we're still trying to understand. What matters is that it reminded us of a simple truth. We're not alone, not in the sense of life, perhaps, but in motion. Our solar system is part of a much bigger neighborhood, and once in a while, something from that neighborhood comes knocking. Oumuamua was the first, it won't be the last. So let me ask you this. If you had one question for a traveler from another star, what would you ask? Let us know in the comments. And if this story sparked your curiosity, don't forget to like, subscribe, and share. There are more mysteries waiting out there, and we'll be right here, ready to chase them before the light.